Okay, let's dive into this highly focused explainer. We're stripping away all the fluff to give you pure, foundational information on exactly how woven fabrics are constructed. No distractions today, just pure facts, engineering, and the mechanics of textiles delivered in an easy-to-digest format. Here's our blueprint for today. 1. Defining fabric and structure. 2. 4 types of fabric. 3. Identifying face and back. 4. Understanding warp and weft. 5. Grain and texture explained. And finally, 6. Reading fabric specifications. All right, Section 1, Defining Fabric and Structure. So we treat fabric as a two-dimensional concept, a planar substance. Sure, it physically exists in 3 dimensions, but we look at it as a flat sheet. The absolute defining characteristic here, though, is flexibility. I mean, if the material is too stiff, it's simply not a fabric. It absolutely must possess a flexible drape that allows it to wrap or fold, and you can make this directly from polymers, fibers, yarns, or even other fabrics. Now, you've got to understand the difference between structure and design. The crucial point is that structure dictates how the materials physically interlock, whereas design provides the visual language. Think of structure like the architectural blueprint of a building. It's how the bricks are actually laid. Design, on the other hand, that's the paint, the wallpaper, or the decorative trim. In textiles, structure is the interlacing method, while design is all about color combinations, prints, or throwing in some fancy yarns. Moving right along, Section 2, 4 types of fabric. There are 4 core manufacturing techniques here, defined entirely by their physical interlocking mechanism. First, woven fabrics interlace yarns, usually one set going up and down over another. Knits interloop them, kind of like a continuous chain. Non-wovens bypass yarns entirely. They bond polymers or fibers directly into sheets using chemicals or mechanical pressure. And finally, braids intertwist 3 or more yarns together, pretty much exactly like a pigtail. For this explainer, we're focusing exclusively on that first category, interlacing woven fabrics. Within woven fabrics, we categorize structures into 2 distinct groups. Simple structures use exactly 2 sets of yarn, one running vertically, one running horizontally, intersecting right at 90-degree angles. This covers, honestly, about 95% of standard woven goods out there. Then you have compound structures, which use more than 2 sets of yarn. You might see extra yarns introduced for complex patterns, or yarns crossing diagonally at 45-degree angles just to reinforce the textile. Next up, Section 3, Identifying face and back. So the face side is simply the technical outside of the garment. It's intentionally designed to be smoother, noticeably more lustrous, and just aesthetically pleasing. It's usually the side getting the prints, colorations, or special piece finishing treatments. The backside, that's the interior. It tends to be rougher, duller, and unprinted. Now, while some fabrics are perfectly balanced or identical on both sides, most have a dedicated face that you've really got to identify through touch, sheen, and print clarity before you even think about cutting. All right, Section 4, Understanding warp and weft. This is where we get into the real engineering. The vertical yarns are called warp yarns, and individually they're referred to as ends. They run perfectly parallel to the finished edge of the fabric, which we call the selvage. Warp yarns absolutely must be highly twisted, finer, and much stronger, simply because they endure extreme tension on the loom. The horizontal yarns? Those are weft yarns, individually known as picks. They run perpendicular to the selvage. Because weft yarns are literally pushed over and under those tightly held warp yarns during weaving, they develop what we call crimp, this wavy bend. This gives the weft direction inherently more stretch, and it's also exactly where you'll usually find decorative or fancy yarns. So here's a question for you. Let's say I cut a tiny 1-inch square right from the middle of a shirt. Without seeing that woven selvage edge, how can you definitively tell which threads are the warp and which are the weft? Well, you can actually physically test the swatch. If you pull the yarns, the warp is going to be much harder to tear because of that high twist we talked about. Warp yarns are also often coated in sizing, a starchy material used to protect them during weaving, so they'll feel noticeably stiffer. Also, if there's a woven stripe, it almost always runs in the warp direction. If you extract a single yarn and it looks incredibly wavy, boom, you found the weft, because it had to physically bend around the rigid warp. Finally, just knowing commercial standards helps a ton. Take denim, for example. The blue yarns are strictly the warp, and the white yarns are always the weft. Moving on to Section 5, Grain and Texture Explained.
The grain is the literal geometric alignment of the threads. For a piece of fabric to be on grain, the warp must be perfectly parallel to the vertical axis and the weft perfectly perpendicular at exactly 90 degrees. This is absolutely crucial for matching patterns when sewing garments. Seriously, if you sew a checked shirt off grain, the pockets will sit crooked, the drape will weirdly twist around the body, and the garment is basically ruined.
Now, if the fabric loses its perfect grid, it becomes off grain, which is a major structural defect. This primarily happens in two ways. First, you have a bow defect, which shows up as a curved distortion in the weft. This happens when the fabric is wound onto large rollers with uneven tension, like tight in the middle but loose on the edges. The second is a skew defect, where the weft sits at a diagonal angle rather than straight across. Skew is usually caused by uneven loom mechanics or just the natural diagonal pull of certain weaves, like a twill.
Okay, our final stop, Section 6, Reading Fabric Specifications.
We define thread density using a term called the set. The set is simply the ends per inch, or EPI, representing the warp density, combined with the picks per inch, or PPI, representing the weft density. Basically, a higher set means a tighter weave. For instance, a fabric with 100 ends per inch will have vastly better coverage, meaning way less light passes through, compared to a fabric with only 60 ends per inch, assuming the yarn size is identical. If you're buying, selling, or engineering fabric, there are 5 non-negotiable data points you absolutely must have. 1. Ends per inch. 2. Picks per inch. 3. The thickness, or count, of the warp yarn. 4. The count of the weft yarn. And 5. The overall width of the fabric roll. Without these exact 5 pieces of information, a merchandiser has literally no idea about the true thickness, weight, density, or cost efficiency of the fabric they're trying to purchase. Because writing out ends per inch and yarn count over and over is super inefficient, the industry uses a standardized shorthand formula. You're going to see this specification formula constantly. But listen, here is a massive point of clarification. Those multiplication and division marks, they are merely structural separators. They are absolutely not mathematical operations. Do not multiply 90 by 80.
So how do you actually read it? Well, because American and British formatting occasionally swaps the order of density in yarn count, your golden rule is simple. Just look at the numbers themselves. The larger numbers, like the 90 and 80, always represent the thread density, the EPI and PPI. The smaller numbers, the 40 and 32, always indicate the yarn count, meaning the physical thickness of the thread. Memorize that rule, and you can decode pretty much any woven specification sheet on the planet.
We've unpacked the pure mechanics of interlacing threads today, moving all the way from the definition of a simple weave to reading complex density formulas. So your homework today is completely practical. Take a close look at your sleeve right now. See if you can spot the rigid warp ends, the wavy weft picks, and check if the grain line is perfectly squared. Once you truly understand the structure, you will literally never look at clothing the same way again.